Hey everybody, so today we are talking about acid-base calculations. So pretty much what you're going to be able to do is you're going to be able to determine how strong an acid or base is by its certain concentration. So you're going to be able to put the strength of an acid and base in a different numerical value other than just that Ka and Kb we talked about the other day. So the first thing we need to talk about when we're dealing with acid-base calculations is we got to talk about the pH scale, which you probably have discussed in some of your other science classes. Well, the pH scale, it ranges from 14 to 0. 0 all the way on the bottom and 14 all the way on the top. Now, it could be greater than 14 and less than 14, but those are for some rare acid and base instances that we won't deal with. And 7's right in the middle. If it has a pH of 7, whether it be an acid or a base, it is going to be neutral. Anything that ranges from 7.00001 to 14 is going to be basic. So if something has a pH of 10, it's basic. A pH of 14, it's basic. A pH of 7.0001, it's basic. And then anything from 7 to 0 or 6.99999 to 0 is an acid. So if it's got a pH of 1, it's an acid. pH of 2 is an acid. pH of 6.9, it's an acid. So that's the first thing to note. Now let's talk about the formulas we're going to be talking about today. And there are pretty much just about 4 of them, okay? First thing is pH. If we want to find pH, we got to take the negative log of H plus, the concentration of H plus. Remember that anything in square brackets stands for concentration. So here I'm taking the negative log of the concentration of H plus, which is pretty much the concentration of the acid. So if I had 0.1 molar HCl and I wanted the pH, you would just take negative log of 0.1 to get the pH, which I'm pretty sure is 1. Okay, in my brain, I just don't have my calculator on me. I should. I'll go get that. So, the negative log of 0.1 is indeed 1. Okay, so that is definitely an acid. So that is our first equation, and that helps us find pH. Well, we can also find this thing called pOH, which is just the opposite of pH. There is also a pOH scale. It's just the opposite. On the pOH scale, 1 to 7 is basic, and on the pOH scale, 7 to 14 is acidic. So we can also find pOH, and it's just the opposite. We take the negative log of the concentration of the base. So if you have 0.1 molar NaOH and you take the negative log of it, it will have a pOH of 1. Another thing we need to note that pOH plus pH will equal 14. So let's say I have a pH of 1. Okay, all I have to do is take 14 minus 1, which is 13, and that will equal my pOH. So if I have a pH of 2, my pOH must be 12. If I have a pH of 10, my pOH must be 14. So all we have to do to go from one to the other is just take 14 minus, right? 14 minus 2 gives me my pOH. 14 minus 10 gives me my pOH. Well, we could also go backwards. If I want something like H plus, right? Say I want the concentration of the acid. Well, I just take 10 to the negative pH. So 10 to the negative pH will give me the concentration of the acid. I'll put that in square brackets. And then say I want the concentration of the base. Well, guess what? It's just 10 to the negative pOH. Okay? So we have 5 equations. We now could find pH, pOH, H, concentration of acid, concentration of base, and we could go from pOH to pH by subtracting either 1 from 14. So those are our 5 equations that we need to have. So now let's do some examples that involve these equations. So the first question I'm asking you is up here in the corner. It says, what is the pH of 0.3 molar HCl? Is HCl an acid? Yeah, it is. It's one of our strong acids. And just so you know, these calculations are only going to involve strong acids and strong bases, okay? Because they fully dissociate. And we'll talk about that another time. So anyway, what is the pH of 0.3 molar HCl? Well, we want pH, right? So if we want pH, we just got to take the negative log of the concentration of the acid. Well, our concentration of the acid is 0.3. So I'll just take negative log of 0.3. Negative log of 0.3 gives me a pH of 0.523. And then I usually just put the pH in. Okay? That's pretty simple. Okay, that's the easiest one you'll get. 0.523 pH. And then if I ask you what's the POH, you could just take 14 minus 0.523 and you'd get a POH of 13.477. Let's look at our next example. What is the pH? What if I ask what is the pH of 0.3 molar NaOH? Okay, almost the same, right? But I gave you a different chemical. NaOH, is that an acid? No, it's a base. So here's the thing. I don't have concentration of acid anymore like I did in example 1. I have concentration of base. So right now, the only thing I could find with concentration of base is POH. So let's just start there. Let's just take the negative log of the concentration of our base and see what we get. Well, if we take the negative log of 0.3, we get the same answer as before, right? 0.523, but it's no longer a pH, it's a POH. Because remember, we're dealing with a base now. NaOH is a strong base. But I didn't ask you for PaOH, I asked you for pH. Well, remember, POH plus pH equals 14, and we could always bounce back and forth between those two, right? If we take 14 minus our POH, it'll give us our pH, which I said before was 13.477. Okay, so you always got to look at what you start with, and always remember that whether I give you concentration of base, you could always get to those acid numbers. Or if I give you concentration of acid, you could always get to these base numbers like POH or concentration of OH minus. Let's go ahead. Let's do another one. What is the pH of, let's go with 73 grams of HCl dissolved in, let's go with 3 liters of water. So here I'm asking, what is the pH of 73 grams of HCl dissolved in water? Well, I want pH, right? If I want pH, I got to have H+. But I don't have H+, right? That's the concentration of the acid. But luckily, right? Remember, concentration or molarity is moles over liters. Well, I gave you liters, it's 3. And I could get moles pretty easily by dividing by the molar mass of HCl. So let's go ahead and let's do that. My mass of HCl is 73 grams. I gotta divide by the molar mass of HCl, which is 1 plus 35.5, which is 36.5. That's the molar mass of HCl. So I'm gonna have 2 moles of HCl. So now I have moles, and now I have liters. So now what I'm going to do to get that concentration of acid is I'm going to take 2 moles divided by 3 liters, and I'm going to get a concentration of 0.66 molar HCl. Now if I ask for the concentration of acid, we would be good to go, but I'm not asking for the concentration of acid, I'm asking for the pH of the acid, right? So all I have to do now is negative log my concentration of the acid, and I'll get my pH. So let's go ahead and let's negative log 0.66, and we get a pH of 0.18. All right. Let's go ahead and do another one. What is the concentration of an acid? Of an acid with, let's go with POH. Let's go 12. Okay, what is the concentration of an acid with a POH of 12? Well, let's look. If I want concentration of the acid, which is this guy, right, H+, I'm going to need to take 10 to the negative pH. Well, I'm a jerk, and I gave you POH. We need pH. How are we going to do that? Well, using this middle equation, right? If I take 14 minus my POH, it's going to give me my pH. So my pH is no longer, or my pOH is not 12, my pH is 2. Okay, so our pH is now 2. Now remember, I want concentration of the acid, so now all I got to do is take 10 to the negative pH, which is 2. And now I get a concentration, I don't even know why I'm putting this in my calculator, of 0.01 molarity. Okay? It's as simple as that. All right. Let's go ahead and let's do another. Determine the pH of, let's go with 0.00032 HBr. Determine the pH of 0.00032 HBr. Well, this is pretty easy, right? Oh, molar HBr, right? You gotta know that's a concentration. Well, this is pretty easy, right? I gave you concentration of the acid, which is H+, and I want pH. So if I'm looking for pH, I got to negative log the concentration of the acid. So all I'm going to do is negative log that 0.00032, and I should get a, syntax error, negative log 0.00032, and I get a pH of 3.49. I'm going to ask you, is this solution acidic or basic? You would say acidic. Okay? The pH is below 7, so it is indeed acidic. Let's go ahead and do one more example. One more, and then I'm done. Okay? And this is going all the way from H+ to OH-. Okay? What is the H+ of 0.0052 molar NaOH? So here, I want the concentration of the acid. Okay? But what I gave you was concentration of the base, right? NaOH is a strong base. So I need to get all the way from OH- to H+. minus. Well, what's the only thing we could really do with OH minus right now? We could only plug it into one place, and that's POH. So let's start there. Let's just take the negative log of 0.0052 and see what we get. Negative log of 0.0052, and we get a POH of 2.28. Okay? But remember, my end goal is H+, and I need pH. But I only have POH. Well, good news is that if we take 14 minus our POH, it gives us a pH of 11.72. And now you're saying, okay, now I have pH. Now I know how to get concentration of acid. I could just do 10 to the negative pH, which is 11.72. And that'll give me my concentration of acid, which is going to be 1.9 times 10 to the negative 12. So that is our acid-base calculations, okay? You should be able to get pH, POH, should be able to transfer between POH and pH by subtracting from 14, get concentration of acid and concentration of base. Try out the practice, check your answers, let me know if you have any questions, and have yourselves a great day.